Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video of ChemSolve. In this video we are gonna solve Cambridge IGCSE Chemistry Paper 2, that's the multiple choice paper. The code for this paper is 0620/22 Feb March 2026. So let's start the paper. A sample of the helium gas is placed in free moving gas syringe. The temperature of the helium is increased. The pressure of the helium does not change. Which statement is correct? So we have to look at the volume. Before looking at the option, just look what is the relationship between temperature and volume when the pressure is constant. So basically, temperature is directly proportional to the volume, and nitrogen being 14 and hydrogen is 1 and there are 3 hydrogens, so the molar mass is 17. So here it is 17 and here it is 36.5. 36.5 is almost double, more than double than 17, and diffusion, the rate of diffusion is inversely proportional to the molar mass. The lower the molar mass, the higher would be the rate of diffusion. So ammonia will diffuse faster, and ammonia is an alkaline gas, so it will turn the litmus paper blue, while HCl it will diffuse slower, and it is an acidic gas, that's why it will turn the litmus paper red. And in this case, the litmus paper will change its color to blue. Why? Because ammonia will diffuse faster and it will supposed to change the color of the indicator paper to blue. That's why the option which says red, it will turn red. This is not correct, right? So why blue? Because molecule of the ammonia move more quicker than the molecule of the hydrogen. Yes, molecule of the ammonia move more quicker. Yes, molecule of the hydrogen chloride will move more quicker. Molecule of the hydrogen chloride will move more quicker. They are wrong option. So the correct option for this question is option A with both the ticks. Okay, so question number 3. X positive 2 is an ion of the group 2 of the element X. What was the highest value in the ion? Okay, so let's see. Maybe we need to look at the periodic table for this question. Okay, so these are all the group 2 element. You can see that for every element, nucleon number is the highest one, right? Okay, and electron and proton number are these. They are the smaller one, and electron number would be even smaller because 2 electrons are lost, right? Look at the options. The nucleon number, I think this is the correct option. Number of electrons, not at all, because we just have looked that all the elements have the nucleon number that is more than their proton number or electron number. For this it is 9, for this it is 24, for this it is 40, 88, 137. Number of electron is not correct. Number of neutron is not correct because neutron number is then subtracted from the mass number and the proton number. The proton number is not correct. So the correct option for this is option A. Okay. Question number 4. The position of the 2 elements P, Q in the periodic table is shown. Okay. So just look Q is from the group 1 of the periodic table and P is in the group 7 of the periodic table. When P and Q react together to form the compound, what is the formula? So P is in group 1, that's why it would have the charge +1. And Q is in the group 7, so it would have the charge -1, right? So they both will cancel out each other and the resulting formula is PQ. Or we can write QP because always positive will come first. Let me make it like this. Q is +1, P is -1, cancel out, and correct formula is QP. So keeping in view, A is the correct option. Which root, question number 5, which root describes the properties of the simple molecular compound? If a compound is simple molecule, it means it would be the covalent substance. If it is covalent, then of course its melting point wouldn't be much more higher. So I think B is not our option. And it will not be a good conductor at all because covalent compounds are the poor conductor. It might be correct. It might be correct. And it might be correct. So C is the correct option. How are the structure of the diamond and the silicon are similar? So the structure of diamond and silicon is something like this. This is the structure of diamond. Each carbon atom is surrounded by 4 other carbon atoms by the 4 covalent bonds. And for silicon, each silicon is surrounded by 4 oxygen atoms with the 4 covalent bonds. Molecules of the both diamond and silicon are held together by weak attractive forces. Not at all. They are not weak attractive forces at all. They both contain atom arranged in planes together by weak bond. No, they are surrounded by the strong covalent bond. They both contain the ions. There is no ion, you can see. I just have drawn a rough structure. The carbon in the diamond and the silicon each have the 4 covalent bond. Yes. So D is the correct option. Solid X and solid Y are both pure substances that contain iron. They contain iron and they both are solid. X is not an electrical conductor, Y is the electrical conductor. Which statement about X and Y are correct? Okay, you should keep in mind that both of them have the ions. Okay, they contain the ions. Y is an electrical conductor. If Y is the electrical conductor, then it should be either metal maybe, or it could be the ionic compound. But ionic compound do not conduct electricity in solid form, so I think only the metal is the option. So Y could be the element. X is not an electrical conductor. If it is not an electrical conductor and it is solid, so it could be an ionic compound or it could be a covalent compound. So X could be a compound. The ion in the X are held in lattice. The ion in the Y are do not held in the lattice. But we just have discussed that Y could be the metal. So if it is a metal, its ion would be held by the metal, so I think this is not correct. X contain both positive and negative ion. If it is ionic, then obviously it will contain positive and negative ions. So this might be correct. Y contain positive ion but no negative ion. Yes, because it's a metal. So it would contain positive metallic ion but no negative ion. Instead it would have the electron. So this is correct as well. So with this discussion we came to a conclusion that C is the correct option for this question. Question number 8. A sample of the magnesium is burned in air. A student calculate 10 gram of the magnesium oxide should be produced. After the reaction, the student determine the percentage yield of the magnesium oxide. Which formula is used to determine the percentage yield of the magnesium oxide? So what is the formula? The formula is actual yield, that is also called experimental yield, divided by theoretical yield multiplied by 100. This is the formula, right? So relative mass of the magnesium, of course not. Mass of the magnesium oxide formed divided by mass of the magnesium used. No, mass of the magnesium oxide, that is we expect from the theoretical yield. Mass of the magnesium oxide formed, mass of the magnesium oxide expected. This seems to be correct. Mass of the pure magnesium oxide, mass of, oh no, not at all. So C is the correct option. Okay. Question number 9 is the mole calculation. 4.55 gram of the zinc is reacted with 50 Cn cube of 2.25 mole per Dn cube of the hydrochloric acid. Reaction is shown. Which volume of the hydrogen gas at room temperature and pressure is produced? So we are provided with two things. We are provided with the mass of the zinc and we are provided with the volume and the concentration of the hydrochloric acid. So what we need to calculate? We need to calculate the moles of both of them through these information. So moles of zinc. The formula for the moles of zinc, we know it would be mass over molar mass. Okay, the mass of the zinc is 4.55 and the molar mass of the zinc is 65. So I will write 65 here. 4.55 divided by 65, it is 0.07. So 0.07. These are the moles of the zinc. Okay. So moles of HCl. For that we will use the formula. Concentration is equal to number of mole over volume, but the volume should be in dN2. The concentration is 2.25 multiplied by the volume, that is 50, but we need to convert it into dN cube. That's why we will divide it by 1000 is equal to number of moles. So 50 divided by 1000, this is 0.05. We will multiply it with 2.25. So multiply 2.25, that would be 0.1125. 0.1125. So this is the moles of hydrochloric acid that we have, right? Okay, now let's calculate the moles of the H2. The ratio between zinc and hydrogen is 1:1. So if zinc is 0.07, hydrogen would also be 0.07. So in this case, moles of hydrogen is expected to be 0.07. And if we will compare it with HCl, then HCl ratio hydrogen, HCl is 2 and hydrogen is 1. So if the moles of HCl is 0.1125, for hydrogen it would be 0.1125 divided by 2. So 0.1125 divided by 2, this would be 0.05. So it would be 0.056. So clearly, in this case, the moles of the hydrogen are lesser. So the actual moles of the hydrogen would be this one, right? 0.056. Okay, now we have to calculate the volume of the hydrogen. So volume is equal to mole into molar volume, that is 24 dm cube. Mole is 0.056. Let me write it a bit clear. 0.05. Multiply by 24. Let's calculate it. Multiply by 24. That is 1.35. So the expected answer should be 1.35 dm cube. This exactly matches with option A. Okay. Now move to question number 10. In the electrolysis diagram, oxidation is occurring at the electrode 1. If oxidation is occurring at electrode 1, then electrode 1 should be our anode. Because anode is the electrode at which the oxidation takes place. And reduction takes place at electrode 2. So electrode 2 is our cathode. Okay. Direction of the movement of the electron in the external circuit. As oxidation takes place at anode, and anode produces electrons, so electron travel from anode to the cathode, right? So electron will travel in the external circuit, they will travel like this. So it would be from 1 to 2, either this, not these. Direction of the movement of the positive ion in the electrode. Okay, as a result of the oxidation, electrons are produced and positive ions are produced, and then these positive ions move towards the cathode. Because cathode is negatively charged, anode is positively charged. So when positive ions are produced as a result of the oxidation at anode, these positive ions are attracted towards a negative electrode, which is cathode. So positive ion move from anode to the cathode. So again, from 1 to 2, not these. With this discussion, option A is the correct one. Okay. Which row describe the advantage of using hydrogen oxygen fuel cell and an advantage of using petrol engine. Okay, so let's see. Can travel a greater distance. Hydrogen oxygen fuel cell can travel at greater distance after the fuel tank has been filled. While petrol engine does not produce carbon dioxide, it does produce. So this is incorrect. This might be correct. There are more petrol filling stations than the hydrogen filling more petrol filling. A and B are the wrong one. It is a minimum energy. Okay, that the colliding particle must have to react. Yes, particles must have to make bond. Not at all. This is the amount of energy that is required by the reactant, so they can collide with each other and they can produce the product. So C is the correct option. Hydrogen peroxide decomposes to form the water and oxygen. The bond energies are shown in the table and the reaction is exothermic. Okay, so let's calculate the enthalpy change. Okay, as the reaction is exothermic, so you must be clear that C and D wouldn't be our option, because in these options the sign of enthalpy is positive, and if the sign is enthalpy positive, it means it is an endothermic reaction, not an exothermic reaction. Now we have to compete between A and B, so let's calculate. Energy of the reactant. Okay, so this is one OH bond, this is another OH bond, so there are two OH bond here and 2 is also here, so there would be 4 OH bonds, and there is also an O single bond O bond. So one O single bond O bonds, 460 multiplied by 4 and 150, 460 multiplied by 4, this is 1840 plus 150, so this is 1990. 1990. This is basically the enthalpy of the reactant. Now calculate enthalpy of the product. So for that I will write energy of product. So let's see, there are again 4 OH bonds, because one water molecule has 2 OH bond and we have to multiply it with the 2 as well, and 1 oxygen double bond oxygen bond. So 4 into 460, that would be again 840, plus oxygen single bond oxygen is 496, so 1840 plus 496, this is 2336, 2336. This is the enthalpy of the product. Now comes to the final phase of the question, that is delta H is equal to delta H of the reactant minus delta H of the product. Then delta H of the reactant is 1990 and delta H of the product is 2336. So 1990 minus 2336, that would be 2336, and the final answer is minus 346. So this is minus 346 kilojoule per mole. This is our final answer, and it matches exactly with option A. So option A is the correct option for this question. Okay, next question is question number 14. Which row shows the source of nitrogen and hydrogen for the Haber process? Haber process is basically concerned for the production of ammonia, like this, and nitrogen is obtained from the fractional distillation of liquid air. Okay, and hydrogen, that is obtained by the cracking of hydrocarbon, for example methane. So with this discussion you can have an idea that D is the correct option, right? Because source of nitrogen is not nitrates and source of hydrogen is not water, it is methane. So D is the correct option with both the ticks. Question number 15. Which statement about anhydrous salt is correct? Okay. So before looking at the option, we should have an idea that anhydrous cobalt chloride is blue in color, and when water is added to it, it turns into hydrated cobalt 2 chloride, that is pink, while alternatively anhydrous copper sulfate, it is white in color, and when water is added to it, it turns into hydrated copper sulfate, that is blue in color. Okay, so let's look at the option. Anhydrous copper chloride turns from white to blue. No, it turns from blue to pink. So this is wrong. Anhydrous cobalt chloride loses water on gentle heating. Anhydrous cobalt chloride do not have the water at all. How could it lose the water? So incorrect. Anhydrous copper sulfate react with water to make the hydrated copper sulfate. Yes. Anhydrous copper sulfate turns from blue to white. It turns from white to blue instead. So this is wrong as well. C is the correct option. Question number 16. The equation represents the reaction of the iron 2 sulfate with acidified aqueous potassium manganate. Which ions is reduced and what is a reducing agent? Always remember that reducing agent is the one that reduces other and oxidizes itself. If something is serving as a reducing agent, it should oxidize itself. So let's see. Oxygen is -2 and there are 4 oxygens, so it is -8. Manganese should be +7, so the overall charge would be -1. Right? Did you understand this? I'm going to write it again here. I need the overall charge minus 1. So oxygen is minus 8 because 2 multiplied by minus 2 multiplied by 4. So manganese should be positive 7. So manganese is changing from positive 7 to positive 2. While iron, it is changing from positive 2 to positive 3. The oxidation number of Mn is reduced. It is decreased from positive 7 to positive 2. And the reduction in the oxidation number, this is basically reduction. Okay, while the oxidation number of the iron is increased, so increase in the oxidation number is the oxidation. Always remember, decrease is in oxidation number is reduction, and increase in oxidation number is oxidation. So reduction is taking place at manganese. This could be correct, this could be correct, but these are not correct. And I just told you that reducing agent is the one which is oxidized itself. So oxidation is being take place at iron. So these are the correct option and these are the incorrect option. So C is correct option. Question number 17. The statement about the aqueous hydrochloric acid is correct. Aqueous hydrochloric acid is a strong acid. We know, right? So it is completely dissociated in the aqueous solution. Yes, because it's a strong acid. And the strong acid are the one which completely dissociate in the aqueous solution. It turn thymophthalein blue. No. It turn thymophthalein colorless. It acts as a strong acid in the aqueous solution. Yes, it's a strong acid, of course. It produces OH negative ion, not at all. All the acid produces H positive ion instead, right? So 1 and 3 are the correct statement, but 2 and 4 are the wrong one. That's why A is the correct answer. Question number 18. Sulfuric acid dissociate in water in 2 stages, like this. This statement about these equations are correct. Okay. So H2SO4 can donate and accept proton. H2SO4. Can you see it has minus 2 charge? It means if we add one hydrogen in it, it will turn into H2SO4. But it also have one hydrogen, so it can donate hydrogen as well. So you can write that if it accepts hydrogen ion, it will turn into H2SO4. So yes, it can accept hydrogen, and alternatively it can donate its hydrogen as well and can turn into SO4 minus 2. So this statement is correct. H2SO4 is a proton donor. Yes, it's an acid and all the acids are the proton donor. SO4 negative is the only base. Yes, because it cannot donate hydrogen ion, but it can accept hydrogen ion. So it's a base. So this is the only base. Yes, it is the base, but it is not the only base. H2SO4 is the base as well because it can also accept hydrogen ion. We just have written here. So it is a base, but it is not the only base. The word only is wrong here. So the correct answer is option A. The statement about amphoteric oxide are correct. What are amphoteric oxides? Amphoteric oxides are the ones which react both with the acids as well as with the bases to form salt and water. They react as an acid with a base and they react as a base with an acid. They react with the acid but not with the base? No, they react with the base as well. They react with the acid and the base to form the salt and water? Yes. They react with acid and base to form the salt and hydrogen? No. Salt and hydrogen are the product of the metal with the acid. They react with the base but not with the acid? Not at all. So B is the correct option. Which property of the element increases across the period of the periodic table? Metallic character? No. When we move from here to here in a periodic table, so what happens? These are all the metals and these are the non-metals. So instead non-metallic character increases and metallic character decreases. So this is wrong. Number of the electronic shell. The number of shell remains same when we move across the same period. Number of the outer shell electron, of course, because the proton number increases, so that's why the number of the electronic outer shell electrons also increases. Tendency to form positive ion. We just have discussed in option A that it changes from metal to the non-metal when we move across the periodic table. So metals form the positive ion, non-metal form the negative ion. So instead we can say that tendency to form the negative ion increases, not the positive ion. That's why the correct option is option C. Now we have completed 20 questions of this paper. Inshallah we will complete the next 20 questions in the next video. Thank you so much for watching. Allah Hafiz. शयान ये कौन सा वक्त है सोने का?